When installing an optional standby generator outdoors, the question arises whether the branch circuit for the battery tender and crankcase heater must originate from the same panel that the generator serves, or if it can originate from any panel. While it is most normal and typical practice for the branch circuit to originate from the same electrical panel that the generator will serve, it is not a strict requirement. There are several reasons why using the same panel is the most common approach. Firstly, it allows for coordinated protection. By powering the generator-related equipment from the same panel, the circuit breakers or other protective devices can be coordinated to ensure the entire system remains safe and protected. Secondly, convenience is a factor. It is typically more convenient to have all the components related to the generator, including the battery tender and crankcase heater, connected to the same electrical panel. This makes it easier to maintain and troubleshoot the system. However, there are situations where originating the circuit from a different panel might be necessary or more practical. In such cases, several considerations must be taken into account. Firstly, circuit protection is paramount. The circuit must be protected by appropriate circuit breakers or other protective devices, regardless of the panel it originates from. Secondly, circuit capacity must be adequate. The panel must have enough capacity to handle the additional load of the battery tender and crankcase heater. Thirdly, coordination with the generator panel is crucial. If the circuit originates from a different panel, it is essential to ensure that the protective devices in both panels are coordinated to prevent any safety hazards. In the specific context of a dairy farm application, where the emergency panel may not be the most convenient panel to grab a branch circuit from, it would be acceptable to originate the circuit from a more convenient panel, provided that firstly, the panel has sufficient capacity to handle the additional load. Secondly, the circuit is properly protected by circuit breakers or other protective devices, and thirdly, the protective devices in the generator panel and the alternate panel are coordinated to prevent any safety hazards. These considerations align with standard electrical practices and the National Electrical Code, although specific requirements may vary based on local regulations and the specific equipment being installed. It is always recommended to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. Here's a more detailed breakdown of the key considerations. Let's start with coordinated protection. When the battery tender and crankcase heater are powered from the same panel as the generator, it simplifies the process of coordinating the circuit breakers. Coordinated protection means that in the event of a fault, the breaker closest to the fault will trip, while other breakers upstream remain closed. This prevents unnecessary shutdowns of other circuits and ensures that only the affected portion of the system is isolated. To achieve coordinated protection, a qualified electrician will perform a short circuit study. This study involves calculating the available fault current at various points in the electrical system and selecting circuit breakers with appropriate interrupting ratings and time current characteristics. The goal is to ensure that the breakers are selective, meaning that the downstream breaker will trip before the upstream breaker under fault conditions. Next is convenience and maintenance. Having all generator-related components connected to the same panel simplifies maintenance and troubleshooting. When all components are in one location, it is easier to inspect, test, and repair the system. This can save time and reduce the likelihood of errors during maintenance. For example, if the battery tender is not working properly, an electrician can quickly check the circuit breaker in the generator panel to see if it has tripped. If the circuit originates from a different panel, the electrician would have to check multiple locations, increasing the time and effort required to diagnose the problem. Now to discuss the circuit protection in more depth. Regardless of which panel the circuit originates from, it must be properly protected by circuit breakers or fuses. The size of the circuit breaker or fuse should be appropriate for the load it is serving and the wire size of the circuit. The National Electrical Code, also known as NEC, provides guidelines for selecting the correct size of circuit breakers and conductors. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their size and insulation type. If the battery tender and crankcase heater draw a combined current of 5 amps, the circuit should be protected by a 15 amp circuit breaker and wired with at least 14 American wire gauge copper conductors. It is important to note that the circuit breaker should be sized no larger than the ampacity of the conductors to prevent overheating and potential fire hazards. Also, consider the circuit capacity. The panel from which the circuit originates must have sufficient capacity to handle the additional load of the battery tender and crankcase heater. Electrical panels have a maximum ampacity rating, which is the total amount of current that the panel can safely handle. Adding additional loads to a panel can overload the panel and cause the main breaker to trip or even damage the panel. To determine if a panel has sufficient capacity, an electrician will perform a load calculation. This involves adding up all the loads connected to the panel and comparing the total to the panel's ampacity rating. If the total load exceeds 80% of the panel's ampacity rating, it may be necessary to upgrade the panel or install a separate subpanel for the additional loads. Let's look into coordination with other panels. If the circuit originates from a different panel, it is crucial to ensure that the protective devices in both panels are coordinated. This means that the circuit breakers in the two panels should be selected and adjusted so that the downstream breaker trips before the upstream breaker under fault conditions. This prevents a fault in the battery tender circuit from tripping the main breaker in the generator panel, which could shut down the generator and interrupt power to the critical loads it is serving. To achieve coordination between panels, an electrician will perform a coordination study. This involves analyzing the time current characteristics of the circuit breakers in both panels and selecting breakers that will selectively trip under fault conditions. The coordination study may also involve adjusting the settings of the circuit breakers to achieve the desired coordination. And specific to the dairy farm application, the dairy farm environment often presents unique challenges for electrical installations. Dairy farms typically have high moisture levels, corrosive atmospheres, and heavy equipment that can subject electrical systems to significant stress. In this specific case, it may be inconvenient to run a branch circuit from the emergency panel to supply the battery tender and crankcase heater. This may be because the emergency panel is located far away from the generator, or because it is difficult to run conduit or wiring between the two locations. In such cases, it may be acceptable to originate the circuit from a more convenient panel, such as a general-purpose panel located closer to the generator. However, it is important to ensure that the panel has sufficient capacity to handle the additional load, that the circuit is properly protected, and that the protective devices in the generator panel and the alternate panel are coordinated. Here are some additional considerations for dairy farm applications. Firstly, use corrosion-resistant materials. Due to the corrosive atmosphere in many dairy farms, it is important to use corrosion-resistant materials for all electrical components, including conduit, fittings, and enclosures. Galvanized steel, stainless steel, and PVC are common materials used in dairy farm electrical installations. Secondly, provide adequate grounding. Proper grounding is essential for electrical safety in any environment, but it is especially important in dairy farms due to the high moisture levels. Grounding helps to prevent electrical shock hazards and also protects electrical equipment from damage caused by lightning strikes or other electrical surges. Thirdly, protect wiring from physical damage. Dairy farms often have heavy equipment and livestock that can damage electrical wiring. It is important to protect wiring by running it in conduit or by using other protective measures. Fourthly, use ground fault circuit interrupters. Ground fault circuit interrupters, also known as GFCIs, are devices that detect ground faults and quickly disconnect power to the circuit. GFCIs are required in many areas of dairy farms, such as wet locations and areas where livestock are present. And fifthly, follow the National Electrical Code, also known as NEC. The National Electrical Code provides comprehensive guidelines for electrical installations in all types of buildings, including dairy farms. It is important to follow the NEC and any applicable local codes to ensure that the electrical installation is safe and compliant. In conclusion, while it is most common and recommended to have the branch circuit for the battery tender and crankcase heater originate from the same panel that the generator serves, it is not a strict requirement. In some cases, it may be necessary or more practical to originate the circuit from a different panel. However, it is essential to consider circuit protection, circuit capacity, and coordination with the generator panel to ensure that the entire system remains safe and reliable. For dairy farm applications, it is also important to use corrosion-resistant materials, provide adequate grunting, protect wiring from physical damage, and follow the NEC. Always consult with a qualified electrician to ensure that the electrical installation meets all applicable codes and standards and is appropriate for the specific application. Remember to prioritize safety and compliance with electrical codes to ensure a reliable and safe generator system. And now a summary of what was said. Typically, the battery tender and crankcase heater circuit for a generator should come from the same panel as the generator itself for coordinated protection and convenience. However, it's not a strict requirement. If you use a different panel, ensure the circuit is protected, the panel has enough capacity, and the protective devices in both panels are coordinated to prevent hazards. For a dairy farm, you can use a more convenient panel if the emergency panel isn't easily accessible, as long as the chosen panel can handle the load, has proper circuit protection, and the protective devices are coordinated with the generator panel. Also remember to use corrosion-resistant materials, ensure good grounding, protect the wiring, use ground fault circuit interrupters, and adhere to the National Electrical Code for safety and compliance in dairy farm settings.